Cool. Hello, everyone. This is another UNIHACK workshop with Elastic. This is our, I think, out of four Elastic workshops, this time about monitoring how to monitor your app with Elastic technologies. Even if, like, you decide, yeah, we hope you do use it because Elastic does have a prize at UNIHACK. But of course, hopefully these skills, and many of these skills should be transferable in your day-to-day, like, actual industry life because monitoring and observability is super important, especially like if you're building new systems and all that. So, yeah, I could testify as being someone who is on call most of the time. It's really good to have observability and monitoring in place just to make sure nothing goes wrong. And yeah, I'll stop chatting around. I'll give the floor to Chintan to uh, start the presentation.
Awesome. Thank you, Terrence. Appreciate it. Good afternoon, everyone. Welcome to the UniHack Elastic session. I'm Chintan Rami, based in Sydney, and I'm the principal solution architect at Elastic. Um, so today's session, we are going to run for about like almost 50 minutes. The first 30 to 35 minutes, I'll cover the concepts and the Elastic solution. So you guys will get some idea what you can leverage within the hackathon from an Elastic solution perspective. And then 15 minutes, I'll be doing some live demo on Elastic Observability in action. Now, we'll start with some fundamentals, monitoring versus observability. Then we move into how Elastic puts it all together. Now, whether you are building this for UniHack this weekend or you're thinking about your career in software, this is the knowledge that kind of separates from junior to senior ones. So let's go into it. Packed agenda. The introduction, we start with winner spotlight. So I want to kind of highlight some of the top three wins last year. Um, this grounds in theory, grounds the theoretical knowledge into sort of reality. So you can see the real projects first, then learn the concept kind of behind them. Then three different parts. The first one is monitoring versus observability. What are the three key pillars in that? Side by side kind of comparison, key takeaways. Second part would be the real world context, some Elastic's challenges, cost, evaluation, slides, so on and so forth, why it matters within the industry. Part three would be the Elastic platform walkthrough. How can you ingest the data? What are those three key pillars, and how we can leverage more buzzing things these days lately about the RAG, Gen AI, AI assistant, so on and so forth. And then I'll dive into Elastic Observability live demonstration. After the demo, we will try to close with the practical guide, and I'll showcase like what was missing from last year's project, archetypes mapped into a specific Elastic integration. Um, and that's about it. And one thing to highlight, as Terence mentioned, there's a prize to up for the grabs. So depending on how you incorporate Elastic solution within your hackathon project, your project will be judged based on that, and then whatever is the best solution, fit solution from an Elastic Lens perspective, will get that prize money out. All right. Let's review what winning at UniHack sort of looks like. Last year we had three winners. The first one, Growth Garden. I'm sure most of you might have already seen it or kind of reviewed it. What was the last year's theme? The first one was the Growth Garden. There were six students from Monash University. It was interesting to actually note uh, one of the judge quoted suggesting it's a thoughtful design and meaningful purpose. It had a very calming vibe, a real problem, very addictive tech, which has AI at the core and a delightful 3D garden experience. It was data stacks and Langflow for the AI backend, which is great. But apparently, the theme could be different, but you can notice that there is no observability layer. So I can think that as an opportunity for you guys to think when you're building something. Make sure you kind of include something from a monitoring and observability perspective. Second one was Shuffle. It's a most technically ambitious sort of project. It had everything, hardware to software to AI to accessibility first sort of design. It's an NFC scanning physical card, different WebSocket, real-time multiplayer. They had CI/CD pipeline from Azure. So it's kind of complex system with many moving parts and exactly where Elastic kind of shines, right? So think about integrating when you're building something, think about integrating from an observability perspective. What can you get out of it? And the third one was Weave. It was an elegant solution to a real user problem. So outfit try on without changing. I wish I could do that, but apparently that was a project which was really fascinating to actually see. From a technology perspective, it was a Golang backend for speed, clever sequential AI image layering. They were using AWS Lambda serverless functions. Again, it's more complex microservices, multiple APIs, AI systems, so on and so forth. So think about again looking at from an observability lens perspective. Um, we will revisit this at the end of the once we finish the demo side of the things. All right, now let's talk about the concept. So what is monitoring? I'm not sure how many of you have came across this monitoring and observability. Hence, I'm kind of going through clearing some concepts. Um, Monitoring has been around since the early days of the operations. So the key idea within that is you decide in advance what you want to watch and you pick your matrix, whether you want to monitor CPU, memory, or response time, error rates, and you basically set some kind of static thresholds, right? Once the threshold breach occurs, then you get alerted. That was the main fundamental behind the monitoring. Now, there are a few things to kind of understand here is known questions. So with monitoring, you can only monitor things that you have thought of. Predefined matrix. So whatever you are deliberately instrumenting, you get those matrix. Static threshold alerts. So it's a rule based. Alert me as an example is alert me when CPU is greater than 80%. And then reactive approach. This is basically tells you something is wrong, but not exactly why, right? So has any one of you probably end up creating a health check or uptime monitor before? Most you might have, and that's exactly monitoring, right? Now, I'm not saying monitoring is bad. Uh, it's kind of necessary, but on its own, it's kind of insufficient when I'm looking at a modern complex sort of systems, right? And we'll actually see more sort of things here. So let's talk about simple analogy here. I'm sure most of you guys are driving. So it's a car dashboard classic analogy, which actually works brilliantly in terms of understanding this concept. So imagine while you're driving, the dashboard shows you different kind of things, right? Speed, fuel, engine temperature, tire pressure, so on and so forth. Now suddenly a warning light turns red. You know something is wrong, but that same notification does not give you more information as in which cylinder is probably misfiring, right? So that's monitoring. It tells you that a threshold was crossed, but the root cause wasn't being identified. Um, what monitoring can't do is if your application suddenly slows down, monitoring might alert on response time, but it can't show you which service in that specific chain is causing it. It can't show a specific user's request path. And crucially, it can't help with the failure that you did not anticipate, right? So think about a scenario where you are working for a enterprise and you're a site reliability engineer, SRE, and your job is to actually keeping the lights on, making sure the infrastructure application is up all the time. And then at one given point in time, you get an alert saying that CPU is 90% packed or memory is crossing the threshold. And you spend an hour or two figuring it out why. So that's the limitation of monitoring alone. Now, if I switch the gear from monitoring to observability, basically it comes from the control theory. Most of you might have actually kind of learned in the past. It's a mathematical concept from 1960s. Now, in software industry, it kind of became mainstream around early 2000s or 2010s, I would say, when the cloud presence came up and the microservices took off, right? So the more complex environment. Um, so the definition for the observability is very powerful. If I were to put in a word, it's like you can ask any question about your system without deploying any new code. That would be the observable system for you, right? With monitoring, if something new breaks, you're kind of blind because it's new. This is not a known thing that you have established some kind of monitoring against those metrics, right? Now, with observability, you can explore and investigate these things in real time, right? So, unknown unknowns, you don't know what you don't know. Think about a peak shopping season like Black Friday. A traffic is going berserk, right? It causes a weird cascade failure if one thing were to fail, uh, which you might not have seen it before. And observability kind of lets you explore that. It does have a proactive nature, so it allows you to detect anomalies before users kind of hit them. And then also kind of provides you the rich context. So it gives you the full story, like what happened, where, why, and which users were kind of affected. So this is more of a concept from an observability perspective. Now, within observability, there are three key pillars that you should be looking at it. Now, every observability platform that's out there, including Elastic, is basically built on these three signal types. Now, first one is logs. Logs basically tells you what happened. Logs are meant to be looked at, right? Why would you log something if it's useless, right? That's how you think it that way. It gives you the information about what happened. It's the most familiar signal. It moves from unstructured text to a structured JSON format. So you would be able to kind of parse those fields and kind of identify different attributes and its value against it. Then comes down to matrix, which tells you how is your infrastructure doing, how is it your application doing. So it's more of a numerical numbers, time series sort of data. Very efficient, low in terms of the storage, fast to query. You can build dashboard out of it. You can use alerting mechanism. You might have heard about Prometheus. So open source sort of thing, right? Prometheus format you're looking up on the screen right now. But again, matrix alone can't tell you why um, when a number is high, right? So the third signal, it's basically the traces. Where did it slow down? It's a most powerful for microservices. An application trace follows a single request across your entire ecosystem of your application, right? Whether it's a front end, it's a middleware system, application, web tier, up until to the database layer, right? So you can basically trace the user journey from these different layers. An example is like payment took 340 millisecond while everything else was under 15 milliseconds. So that's basically the bottleneck that you are able to find out. Without traces, finding this could have taken many hours, right? So for a fully functional observability system, what you need is all three matrix or all three signals. Matrix can alert you, logs can explain what happens, and traces will show you where. If I'm looking at the difference or comparison here, um, from an approach perspective, monitoring is always reactive. You find out when it breaks versus observability, it's more proactive and more exploratory. Um, Then, from a focus perspective, monitoring only covers for the failure modes, whereas observability, you can ask any kind of questions to that system, right? And it will be able to kind of surface that information. From a data type perspective, monitoring will have like matrix and basic logs. Observability, you will cover with these three different sort of pillars that we talked in the previous slide. Um, you can ask questions in terms of is it working versus why is it slow? And if I compare these two systems, one would be considered as a binary, whereas the other one is diagnostic. Um, Tooling perspective, the dashboards and alerts that you see in monitoring versus the distributed tracing and the APM and more agentic AI and RAG sort of use case from the observability solution perspective. Um, for your UniHack project, think about whatever technology that you're using, even a front end, back end, or a database setup. Uh, you can take the benefit of the Elastic system to incorporate these signals from all these three different pillars, right? And showcase how you can leverage, how you can monitor, how you can create an observable system of yours and show the power of it, right? Um, Monitoring kind of tells you what is broken. Observability will tell you why it is kind of broken. Um, Now we understand the concept. Next, what I want to do is why should you actually care, right? So let me show you some real world numbers so you will get some perspective. So this is more of a real world sort of context. You will see the chaos in this picture. This is exactly what it feels like when you have. So when I talk to my customers, I get a lot of problems like this. Hey, Chintan, you know what? We have different silos. I see there's a tool for logs. I see a tool for APM traces. I see the tool for matrix, but they are all siloed environment. And when one thing were to go down, I can't put all these things together and kind of correlate that, right? So that's more of a domain silos we are looking at it. Tool sprawl. Think about big enterprise where you have like multiple of these kind of tools, and context switching becomes such a nightmare scenario. There's also a finger pointing thing. So a war room scenario when things were to go down, and if you have these domain or tool sprawl somewhere, and every one of these tools are saying that, hey, my infrastructure is hunky-dory, everything is green. I don't see any issue. My application is working fine. I don't see any issue. My database is fine, right? So this is where the finger pointing comes in. Burnout is something of productivity, right? Think about like you being an SRE or working with the NOC and you're monitoring the system and you get woken up at 3 a.m. without any context. Obviously, your morning is not going to be that good. You're going to be grumpy even after having 2, 3 cups of coffee, right? So one of those things that we from an Elastic run into with our customers all the time, and we kind of help them out. Like, how can we bring more visibility from your application perspective? Then you're looking at a downtime. So whenever the application goes down, what's the major impact? It's basically your end user who's consuming your service. They get frustrated, right? So that's more of a downtime. This is more of a real world sort of context. I want to actually draw an attention here in terms of the number. Now, I'm sure most of you have actually encountered that outage from Facebook Meta back in 2021, where Facebook, Instagram, WhatsApp all went down for nearly 6 hours. That 6 hours downtime kind of translated into $65 million damage. Similarly, for Delta Airlines in 2026, there was an IT outage which caused a massive operational disruption, and more than 2,000 flights were canceled. It was utter chaos, right? Lot of money involved in it. Now this is not something it has. I have come up with this number. This is actually very well documented numbers that are out there, right? So you might think, I'm just a student building a hackathon project. Does this apply to me? Why is Chintan talking to me on all these front? These are the same principle that applies to you. So think about within UniHack, you're building something and your demo or something crashes during the judging time. Then what? Are you gonna scratch your head, scramble around, see what's happening, right? Having this kind of visibility might give you a perspective. Hey, this is broken. Let's go ahead and fix it, right? It kind of gives you that perspective. So what's the solution? Now let's look at how the industry has sort of evolved. From a timeline perspective, early 2000, you had a health monitoring, fairly simple monitoring, focus on knowns and no, unknowns, alerting engines and manual triage. Then come into mid 2010s, again, siloed observability tool, but they were desperate, right? They were a separate tool for logs, metrics, and traces. It was quite all over the place. Now, if you talk about the current recent time frame, you're looking at AI-driven open source observability, where people are talking about like, hey, I don't want vendor specific tool. I don't want proprietary tools. I want to actually move into more open source side of the things. That's where the open telemetry comes into the picture. That's where the AI, large language model comes into the picture, right? And this is what Elastic is building. And you're going to actually see how we can help you building this kind of observable system even within your project. So let's see what it looks like in practice. So now we have covered why. We have seen the real world cost. Now let's talk about how, right? So you don't need to build any of these from scratch. Elastic has done the hard work. It's a single unified platform with all those three pillars, which you were looking at earlier. Elastic allows you to ingest logs, matrix, and it allows you to instrument your application using either Elastic APM agent or you can use the open telemetry, right? You might have actually heard about back in the days, Splunk and Greylogs were only used for logs, Prometheus and Grafana for kind of matrix, or Jaeger and Zipkin for kind of traces. Again, different sort of tools, right? But with Elastic, everything comes under one umbrella. So meet Elastic Observability. On the left-hand side, what you are seeing is any data, any source. So whether you use the Elastic agent or you use the open telemetry, the application or the project that you are running, you might be able to send the data or you will be able to send the data into Elastic by those means. And Elastic ingest both operational data as well as the business data. So think about the operational data, logs, matrix, and traces, what we have seen earlier, and business data from a corporate and enterprise perspective, some kind of revenue matrix or customer events, that kind of stuff, right? On the center, what you're looking at is the AI-driven engine. So once the data flows into Elasticsearch AI platform, it is not just a storage, it's more of an intelligent AI platform. So it continuously analyze the pattern, detect anomalies, and it will generate insights in the form of dashboards, in the form of machine learning algorithm, anomaly detection, alerts, SLI, SLO. There are so many things that are out there inbuilt within the platform that you can leverage. And on the right hand side, it's more for business outcomes, right? So you can improve on your user satisfaction, improvement on your dev productivity, and kind of reduction in revenue disruption. Uh, there are three different offerings from an Elastic perspective. We run our Elastic on public cloud, hybrid, and on-prem. So the flexibility of any kind of environment. What you guys will end up doing for your UniHack project is I'm going to post something in the chat window where you can register for the trial for 14 days. So for UniHack project, you will be able to kind of establish the Elastic cluster, serverless project. You don't have to do anything. And all you have to do is just point out your data into that instance and you can gain all these insights. Now, if I actually kind of dig a little bit deeper into this Elastic architecture, at the bottom, you're seeing the different sort of deploy anywhere scenario, public cloud, hybrid, or on-prem. Then you see the platform, which has hotel first sort of um, uh, initiatives, right? We don't lock in our customers with our proprietary stuff. You can bring in open telemetry, community-driven stuff. We have more than 350 integrations, so you can ingest data from almost anything that's out there. It's a search AI lake. So once the data comes in, you can leverage the search aspects of our platform and then do a data exploration. It's a free form sort of investigation. Then it comes out to Elastic Observability. So we do have three different offerings: search, observability, and security. We're going to concentrate more on observability. Now, within the observability layer, what you have is those three key signals: logs, matrix, and APM. There's also continuous profiling that's out there, digital experience monitoring, and AI ops, including the AI assistant, large language model, agentic AI. I think we have another session or webinar tomorrow that goes to show how you can leverage the agentic AI framework and the workflow from an Elastic Lens perspective. I'm gonna go into more Elastic features that how you can leverage Elastic's offering and also kind of incorporate within your UniHack project what you're doing. Um, so simplified data ingestion at scale, whether you use Elastic Agent or any kind of integration or OpenTelemetry, you will be able to ingest logs, matrix, and traces. It's a simple install, and that can provide you all three pillars. We do have a fleet management where you can centrally manage these agents that you are deploying to collect the data across your entire infrastructure. What that fleet management allows you to do is with simple policy updates, you can roll out those configurations centrally and make changes to all of your agents without touching anything, right? So think about your front end. You need to collect certain set of matrix. For your middleware database, that could be something different, right? So you create different policy and then you apply to those agents. That will be only the one-click policy update through the fleet management. Again, there are more than 400 out-of-the-box integrations are out there. So whatever you are using, let's say AWS Kubernetes or PostgreSQL or any kind of agent like Node.js, Python, Docker, you will have the ability to start leveraging those integration. Those integration basically gives you the built-in assets that you can leverage without putting any kind of effort, understanding your data, parsing those fields, creating pipeline, and then it would make sense to surface that information, right? So we take care of that, use the integration, apply the policy, and voila, you will get all the details out. So for your project, you would install the Elastic Agent or maybe use the APM SDK in your language of choice, maybe Python, Node.js, Java, and within few minutes it will start flowing. No complex setup. The next thing is logs. So this is one of the first pillar that we talked about in Elastic. What makes Elastic Log special is we have the AI-powered log categorization. So think about when you're sending um, log file, thousands and thousands of lines in it. You don't want to actually sift through every single line. Within our platform, there's a machine learning algorithm that actually kicks in and automatically groups the similar log messages into the categories. So instead of reading these raw lines, you will be able to find out with one click to kind of investigate. So on your screen, you're looking at it. There are returning ads, unknown stream removed, terminating due to Java lang out of memory, Java heap. There you go. And it has the maximum anomaly of 72, right? That's actually gold. You can quickly drill down into it and then kind of gives you more context to get into a specific application or the infrastructure. So in context, when you're clicking on it, you're not losing context, right? You're able to kind of get to the bottom of it. So this is very very crucial and very very important. Think about from UniHack project perspective. Whatever you're building, if there are logs out there, then go ahead and ingest it and use Elastic Observability Platform to kind of showcase the power of it, how you can leverage it. The second pillar, application performance monitoring, APM, it's a trace pillar. So in the screenshot, what you are seeing is there's a service called Edward Service. It has been instrumented, and once the users are going onto the browser and accessing a URL. Basically, they make some transaction and somehow this service gets called. What it does is it kind of gives you the latency distribution, how my transactions are laid out from a latency perspective. On the far right, you see 2 second, 3 second, 4 second, whereas on the left side, you see a very quick response. So left-hand side ones are pretty good. On the right-hand sides are the transactions that are users kind of complaining or not getting the best value out of your application, right? You see the waterfall chart, it kind of gives you the latency distribution. The beauty of the application performance monitoring with the traces is you know exactly the journey for user. You know your application codes getting called, what kind of calls it's actually making, what kind of methods are getting called. And even within that, you have really good insight about sub calls, sub methods as well, right? So you really get end-to-end distributed tracing across microservices. There are machine learning powered health indicators that are out there. We'll see that in a demo, right? So again, if I'm looking at from your UniHack project perspective, let's say if you're building something on Python or Java or Go, any kind of language that you're using, what you can do is you can download the Elastic APM SDK or OpenTelemetry SDK, and then literally within 2 or 3 lines of code that you inject, and it will start giving you all this kind of information. So every database query, every external API calls that you're making, you will be able to uh, see it. Finally, the matrix pillar. So in the screenshot, what you're seeing is even within UI, we are able to kind of give you insights about how your infrastructure is performing using matrix. So in the screenshot, you're looking at AWS and Google Kubernetes Enterprise GKE clusters. The heat map, it kind of gives you that there are multiple Kubernetes pods that are out there in specific region. The darker the color, it's higher the CPU, so you can instantly see which pods are hot. When you click on those darker color pods, then you will see these hyperlinks where it allows you to get into the logs, the matrix, the APM traces, and probably the uptime, right? So think about you are hosting an application on an infrastructure. Traces give you the more historical view or more real-time view of how user journey from application code perspective. Logs give you information about the application side of the things. Infrastructure view allows you to see how your backend infrastructure is performing, which is hosting your application. Is your CPU spiking? Is your memory spiking? Is there a domino effect to your application, right? So in context, you have these different drill down capabilities that you can leverage. Again, similar analogy, there are multiple integrations out there which you can leverage. Uh, yeah, so this is more for the infrastructure monitoring. Now, this is the most exciting part of Elastic right now. That's an AI assistant. I'm sure many of you have come across a lot of these AI tools. You guys are using it left and right. Um, it's the industry's first RAG-based AI assistant for observability. I'm sure you know what RAG is. It's a retrieval augmented generation. So it means that the AI has access to your data. So not just a general training knowledge. Basically, if I'm looking at Claude or Gemini or ChatGPT, and you're using those and you start asking some questions, and the model basically, whatever the knowledge or the trained information that it has, and whatever the information available publicly on internet, it will give you information based on that. But with our AI assistant, Elastic AI assistant, it's basically integrated with your data. So whatever you are ingesting within Elastic, it does leverage the large language model and using the retrieval augmented generation, and without any hallucination, it will give you in context answers. So in terms of, hey, why is my application slow? It will basically give you all the information that resides within Elastic, right? Now with AI assistant, also what you can do is you can definitely ask natural language questions. You can build dashboards, which we are going to see that in a demo, build charts on the fly. There are certain languages within Elastic that you don't have to know, such as Kibana query language, and the latest and greatest addition is Elasticsearch query language, ESQL, which is basically goes with the SQL sort of language, right? You don't need to have the knowledge of that. You can just in natural language you can ask question. This AI assistant will explain the log messages. It will explain the APM errors in plain English, like what exactly it is, right? So it's very, very powerful. On the back end, if I'm looking at it, it's actually powered by Elastic's own semantic relevance engine. It combines the vector search with traditional keyword search for hyper-relevant sort of result. Uh, Again, similar sort of thing is like imagine from your UniHack project perspective, asking why did my API start failing 10 minutes ago? If something were to go down in your project, right? You can ask this question. Or if everything is working fine, you can still think about coming up with some kind of natural language where you want to use the chatbot and you want to surface some information which is very easy to digest for your judges, right? So something to think about and get some direct answer pointing to your exact information that buries within your data that you have pushed within Elastic. So that's AI assistant within Elastic now. We also have something called as a service level objectives and also synthetic. So this is how professional teams kind of defines what good looks like. Think about I want to monitor my services. Like 99.9% of HTTP requests should complete under 200 millisecond. So anything outside of that, I want to alert, right? My API should be available 99.5% of the time. That's what I want to monitor. Anything outside of that, please give me an alert, right? So Elastic kind of allows you to define those service level indicators and eventually these service level objectives. You can see the compliance, you can see the burn rate. It warns you before you breach your SLOs. So why does this matter? SLOs are how companies make promises to their customers, right? If you look at AWS has something called as a 11 nines, right? That's their availability SLO. So this is basically how they start monitoring how their application, how their services are performing, and then hold the engineering teams accountable using those metrics. Think about from your UniHack perspective. If Judge asks you, like, what's your app's reliability? Well, if you have built SLO, then you could actually show them SLO dashboard that the availability is 99.99%. That's very impressive, right? It's more of a data driven. You're not only talking, but you can basically talk through most of the stuff. All right, let's get into the demo side of the things. If I can now before I kind of do that, what I want to do is, Terrence, I'll be able to put the information on how to register for Elastic trial.
I can distribute that to all the students in the participants handbook if you give me that information.
Okay,
So that
all right.
should,
I've just copied anyways
yeah.
into the chat. Hopefully people can see it. And if not, maybe if you have the way of doing it, can do
Hmm.
so. Look, there are a couple of things that I've actually put it in. Very good. I would strongly recommend to sign up for the serverless so you don't have to do anything uh, in terms of building the Elastic infrastructure. With simple few clicks, you will be able to do that. Elastic will be able to deploy the Elastic stack for you. It will have all the information, the endpoint, the API endpoint, so on and so forth, where you need to point your data to. And then the second link is more of a demo gallery, which gives you a view of how you can ingest the data, how you can get going initially, right? I am going to show you one basic thing. Once you sign up using that serverless link with your email address, it's a 14 days trial. You don't have to do anything. It's a free. Um, then you will be able to kind of come to this sort of screen. Terrence, you're able to see my Logs Essential launch screen?
Yes, I can say the serverless
Perfect.
project, yes.
Okay. All right. So in this case, I'm just simply creating a create serverless project. Then you will see three different offerings. As I mentioned, we have Elasticsearch, security, and then observability. So in your case, you're gonna probably do select the Elastic Observability. We'll do that. You name your project. You will have an option to pick and choose cloud provider and region. Doesn't matter. There will be three option, AWS, Azure, and GCP, and then different sort of region. From an edit setting perspective, it's your sort of option what you want to choose. You can either choose complete observability or you can choose logs essential depending on your UniHack project. If you want to inject everything, logs, traces, and matrix, I would suggest go ahead and select complete observability solution. Or if you're just only sending logs, then just pick and choose observability logs essential. So we're gonna click on that, and all I'm doing is create serverless project. Within few minutes, it will give you a notification, and then all you do is just click continue. Once you click continue, the second link, the demo gallery of serverless, review that. It will give you perspective as to when you click on host, Kubernetes, or cloud, it will give you an option how to inject the data, right? It will have all the command line, it will have all the information, what you need to paste and everything, which will get you going. For the demo purposes, what I'm going to do is now I have ingested some kind of data already in, and now I am looking at the alerts page from my observability view, and it gives me that there's a document count of 139 above the threshold. Threshold value is 70. So I'm going to click on that, which gives me more information about an overview of that alert. Threshold breach, alert when greater than 70. I see a bar chart here. At this time, the volume was here, then it got up, down here, right? And then the alert kind of triggered. Then I see the history as well. What I'm going to do is I'm going to open in Discover. Now, Discover is a place where you see all of your data comes in. So whenever you're sending logs, where do you see it? This is the place where you will see all your logs, right? There are different data views that you can create using the index pattern. You select that and it gives you that information. Right now on the UI, all I'm doing is filtering everything with the log file path with this location. So it gives me that information. I'm going to select the first log and expand that. And it just basically gives me a lot of metadata information, log file path, data set, where is it coming from, which stream, what's the shipper, so on and so forth, right? Kind of gives you that more perspective. I've talked about the Elasticsearch Query Language, ESQL before, and KQL. We are going to actually take a look at it. How can you leverage the ESQL to query the data and get the most out of the logs that you see? Um, so basically this query, what I'm doing is I'm running a query from the logs MySQL. This is the index that I'm looking at it. And I want to surface or I want to create this is my condition where I'm only looking for the file path with this and log level equals error. Then I want to actually get the count, right, against those message. And if I run that, now I have a good visualization here. It tells me that count 322, and the error message kind of says that the table order is full. So that's basically the error message that I see, right? So that's one example. If I look at another example is I need to look at the response code visualization. I click on it. It's the query that I'm looking at it. Anything from Nginx access logs that I'm getting, I'm setting the timestamp for last 3 hours. And then what I'm doing is I want to find out the response status code greater than or equals 400 and less than 400. I want to actually create that category first. And then after creating that category, I want to count and then sort that by the status category. So as you can see, it has given me the results. Less than 400 status code, 7,482, and greater than or equals 400, these many messages that I see. What I want to do is I want to actually find out the global sort of impact from that same Nginx access log, right? If I see more than 400 status error code on that many log lines, I want to find out which regions are impacted, right? So even log has this information. So using this ESQL query, I'm now able to identify the country name. So I'm looking at last 3 hours window, anything greater than 400 from a response status code perspective, but then do a count against the country name and then put it into a descending order. So there you have it. So now I have the United States, France, Germany, so on and so forth, which gives me really good information. Now, the good thing about this, whatever you saw here, we were able to create a lot of visualization. So finally, what we want to do is you can basically using those saved ESQL query, you can put all of them into a simple, nice dashboard. So when you're looking at your application's health, you will be able to identify. So in this case, I have the Nginx logs, where my users are coming from, map them geographically. So I have that view. What is the response codes over time? So I have that clear distinctions, right? 200s, 300s, 400s, 500s. Then I want to actually see some business context. What's the total revenue at risk for the selected time frame? What's the total revenue for the selected time frame that I'm seeing it, right? What is the revenue? And moreover, without even doing the traces, what I'm getting here is I'm getting the top pages. So where are my users coming from and what are they accessing? So only looking at the APIs, I'm looking at the orders page. I'm looking at the recommendation page. I'm looking at the cart page, login page, right? Think about the microservices environment where every single one of these microservices are spitting some logs and you have the identification or means to send that information in Elastic. And this kind of dashboard allows you to see the traffic against your specific page, right? This is really, really impactful and very useful for you to kind of review. Now, let's switch into another demo. Give me a second if I can. Hopefully this kind of makes sense up until now, and you're probably getting the value out of it, like how you can leverage Elastic solution while you are building something over the weekend for your UniHack project. Now I'm gonna actually switch more into the traces, the matrix side of the world, right? This is the observability UI. So when you create a serverless project, when you start ingesting the data, you will start seeing this kind of panel. This is the observability overview where you will see the alerts, different kind of alerts coming in. There's a logs event, there's a host service inventory. For demo, what I'm going to do is I'm going to go into the application page and I'm going to switch into the monitors. Now, this is a synthetic monitor. Um, just a quick overview of synthetic monitor. It's just basically think about you are visiting Amazon, you're visiting eBay, you are searching product catalog. Once you find that, you're clicking on that one specific item. Now within that page, you're clicking somewhere, let's say for review. Before buying or making any decision, you want to see the review. After looking at the review, now you think about, okay, I'm gonna actually buy this. So you put that into the cart. Then you click on the cart view, which gives you the list. Then it goes into the billing information. You punch in all your credit card or any payment information, and then you actually do a checkout. So that's a journey, right? Synthetic monitors are something which allows you to mimic that user's end user's journey So if your enterprise is hosting those services or providing those services, you have means to actually create those synthetic monitors. Elastic kind of provides this ability for enterprises to monitor something using the bots that are out there. So you saw the AWS, there were some regions, then Azure, GCP. So all these cloud providers, we have our different regions set up and we have bots selected. So you can, when you're building monitors, you can pick and choose the location. You upload your scripts, those steps, and it will basically do the transaction. Once you do that at a set interval, it will start monitoring that for you. So before anything were to go wrong on your application, or at the time of something were to go wrong, and before customers start complaining, these kind of tests gives you the proactive nature. It will give you the alerts automatically before your customers complain, right? So these are the things that we have set it up. This is an empty cart sort of scenario where users are not able to empty their cart. It just stays as is and they can't proceed further, right? So I'm going to get into this specific monitor. So I simply click on Go Monitor. Then I have the details about this monitor. What has been set up, the URL, when was the last run, what's the duration trend look like from a percentile perspective, summary, the status. I have all the details of my different steps. So this test is actually going to do first step, navigate to home page, then click go to shopping button, select the Explorer refractors and add into the cart and then empty the cart. The first four steps are good. Everything is hunky-dory. The fifth one, it actually failed, right? If you click on it, it kind of gives you more waterfall chart as well. It gives you all the details and then it kind of gives me the error as well. What I want to showcase here is if I go back and then I want to actually click on the alerts page. If I refresh, I will see that. I'm going to expand my alert and here I could see a lot of information. Now, interestingly, I could see the affected entity in the source, which is basically a service name card. So if I click on it, now you will see we were initially on synthetic, but in context, I have moved into my service inventory. Now, this inventory is nothing but the APM or the open telemetry, the services that we have instrumented. Here, we are seeing the card services that runs on .NET and on Kubernetes, and we are instrumenting it with OpenTelemetry. You will see different tabs in here, overview, transactions, dependency, errors, and matrix, and so on and so forth. Usually you will see the latency chart here, so how your application is performing. There are different throughputs, different transactions that you see, failed transactions, so on and so forth, right? And I could see the errors as well, failed transaction, and also certain dependencies. So upstream, downstream dependencies of that service, how they are connected. Now we saw there was some failed transaction rate on this empty card, and I see some error messages. So what I'm going to do is I'm going to click on this. That took me from overview directly into the errors tab here. Now here I have the bar chart here. The error occurrence and what is the baseline or comparison with week before, right? So it kind of gives you more perspective. There is an error sample. I could see the log messages, but hey, who knows? I am not familiar with this app. So what I'm going to do is I'm simply going to ask my AI assistant to give me more information about what's this error, right? Really, really useful when you have no idea about your application that you're monitoring. You can basically leverage this AI assistant and it kind of gives you more information. So voila, it kind of gives me the exception details, the type, the message, the service, what's the root cause, the likely cause for it, and what are the next steps that I could see, right? This is very, very handy. Now, the next thing, what I want to do is I want to start the conversation with this service. So I want to ask a question is, can you show me a bar chart of the count of log levels which are not null and from log stars for card service logs over the last 3 hours, specifically for logs where the messages field mention Redis. In a natural language, I'm actually constructing my Elasticsearch query that will surface some information, but I'm actually going to ask them to create a bar chart. So if I do that, it will go ahead and start looking at function calling, and then it will start generating this good information for me. Turns we are dot at 5, but I think I probably need another 2 or 3 minutes just to wrap up. Should be fairly quick.
Yep, works for me.
Right. So as you can see, it's actually going through all this different events, function calling, and now it has created different bar chart here, information and error messages. The next thing I need to ask is this a known issue? It will, if there are any kind of GitHub, ServiceNow, any other information out there within my Elastic, then it will tell me. There you go. Yes, it's a known issue with card service. There's a card service runbook, and this is what you get out of it. There you go. It did actually say, is there a run books, but I'm still gonna ask, is there a run book for that? Please create cause. So now there you have it. I have a run book available at this place, so someone can click on it and they can get some more information. Now, from an enterprise perspective, what happens is when you are going through all these data, you're surfacing all this information, there will be some ITSM sort of product ticketing system where you need to log this information. So in this case, what I'm doing is I am simply asking my AI agent to um, log this into the Elastic case for me. So if I do that, and then if I go into my cases view, and then I come here, go to alert, I should come up. There you go. I have one here, assigned card service Redis connection. I click on it and voila. Here I could see the error detail error message, runbook information, and GitHub reference issue. What I can do is I can basically assign the user and I can attach the severity and I can even probably comment a little bit more and I can start asking or I can start providing more information and start collaborating with my users. All right, so what I want to do next now is just a recap, and I want to showcase one last thing for you guys is again kind of revisiting. We had these three projects from last year, right? Growth Garden, Shuffle, and Weave. If I am looking at it a little bit more from a detailed tech stack perspective, the first one, Growth Garden style, was AI powered app. They were using Next.js or Python app. What you can do is you can install the Elastic APM SDK in that project. It's just a two-line of code. You can structure your logs as JSON with some useful field, user ID, action, duration. You can create an SLO for your API response time, right? And during your demo, you can then open APM and show the traces of an AI call. Judges will love seeing that kind of information. The second one is shuffle style, real-time hardware sort of information. Install the Elastic Agent, auto-discover your system, start collecting matrix immediately. Convert your WebSocket event handlers into a log structured events into Elastic, right? And show some real-time dashboards with it within Kibana. Uh, Weave style, the last one, API chained app. You can use Go APM agent, instrument that and do a transaction, and every step of the way you will be able to kind of start seeing the span or the traces within API. Um, Again, a critical tips for you is what you would need to do is use the free tier, register yourself, serverless, I would say, sign up for it, It's a 14 days trial. Uh, the demo link that you have seen, that's pretty handy, useful for you to review few things, whether you're using Elastic for the search or observability or the security side of the things. You will be able to kind of see how you can ingest that information. Um, and that would be easy enough, or for you to kind of get into more um, showcasing how your UniHack project translate into more observability or a search or security use case perspective, and showcase the value for your project. That's all from me, Terrence. I hope session was kind of useful.
Yeah, yes, definitely. I think you just went through some of the potential integration points from using some of our past winners. So that will give you a sense on, like, I guess, how you can best use Elastic in terms of, especially if you want to try and aim for that prize. I guess, I guess we're over time, so I guess unfortunately
Yep.
there's no questions. But you will be available during the weekend as a mentor.
Yes. Yep.
So yeah,
I'm in
so
Sydney. Yeah, I'm in Sydney, so me and a few of my colleagues are planning to come on site Saturday and Sunday. So if you have any questions, feel free to reach out. We'll be available, and there are other means to reach out as well. Terrence might, or you guys might be able to see information available website. So reach out if you have any questions, and we are more than happy to help build
yeah,
your project.
no worries. And as well, like there's also the Discord as well. So yeah, we'll leave it there. We will decide the winner of the gift card uh, at the end, probably more on the Friday, just because we're super busy with all the UniHack stuff. But we'll let the winner know. We have the list of attendees here based on the Zoom call, so it should all be good. So yeah, thank you
Easy done.
everyone. Yeah, thank you everyone. Thank you, Chetan, for presenting,
Awesome.
and I'll let everyone go. Have a good evening.
Thank you, Terrence. Thank you, everyone.
Cheers,
Bye.
everyone.